Hello, I'm David Dickey. I'm a research technician at the University of Arkansas Division of Agriculture. Today we're going to talk a little bit more about irrigation and some parts that we typically use in drip irrigation here at the university and on small farms in the area. What I would like to show you today is we have a different type of fertigation loop that helps support a drip irrigation system on a local farm. It's a little bit different, same principles involved in what we showed you earlier in our high tunnel strawberry plantings. But this one is a little bit different, and the main thing is that this system has a lot more flow capacity than what we have in the high tunnels. First thing I'd like to show you is this hose hooks into your water source. This hose here is hooked up to your water source. This system is pretty much designed on a 1.5 inch. The water flow that goes through this system is no more than 25 gallons per minute, which is considerably more than what we are using down in our high tunnels, where our maximum flow that we can have there based on our system is probably a little over 5 gallons a minute. With the next part of this system is a filter. Then we have a stop valve that keeps water, a backflow valve from backflowing into the system. Then we start our fertigator loop here. As you can see, we have a valve here and the hose that goes to our fertigator unit. Then the output hose on the field side. Again, like we had shown you in the high tunnel, we have a bypass constriction valve on the main line to restrict flow, create back pressure to operate the fertigator. Then on our output side, here's a 2-valve manifold, so you can control where the water goes once it goes through the system. As we had mentioned before, filtration is extremely important for drip irrigation systems, and the filter on this particular unit is different from the one in the high tunnel we showed you earlier. Though the cartridge looks the same, this filter here is actually a self-cleaning filter, and it has continuous flow going out of the filter all the time. Now this is set up on a well that has quite a bit of sand and some dirt in it, and the self-cleaning filter allows you to run your irrigation continuously and not have to stop and clean your filter out that often. Because remember, you could be putting this unit here can run at 25 gallons a minute for days, weeks on end. However, what I've noticed about this particular one, usually once a day the filter does need to be taken out and cleaned, and then put in, then it's good to go for probably another day. The disadvantage to this type of filter is that you'll probably lose a gallon, maybe 2 gallons per minute of water, depending on the amount of trash that's coming through and hitting your filter. If you have more trash coming through, you're going to have to increase the flow with this little valve on this particular filter. Again, on any drip irrigation system, or any irrigation system in which you're using a fertilizer injector, there's some kind of chemical, whether it be fertilizer or pesticides, going through the irrigation water by some means. You have to have a backflow preventer valve. In this case, the well has a backflow preventer on it, but this loop right here outside the well has a backflow preventer. Anytime that you're using municipal water sources for irrigation, there's no question asked, you have to have a backflow preventer on the system in case, and the reason this is in case the pressure for whatever reason gets shut off in the municipal system or the well. There could be a suction that might pull chemicals or fertilizer back down into the water source to contaminate it. So always remember that, especially on municipal sources, that you will have to have a backflow preventer. Going back through this, I'll talk about this particular injector. The injectors that we're using in the high tunnel greenhouses are very, very small. Because we're dealing with relatively small flows to our strawberry plants there. We don't have a very large planting, and thus the water usage is lower than in some field situations. Each fertigator unit that has flow through capacity that works off water pressure differential has a specific maximum flow rating and a minimum flow rating that will cause the machinery inside to operate and inject fertilizer solution into your lines. The ones that we showed you before have a maximum flow rate of 3.5 gallons per minute. This particular one is more robust, and it will handle 20 gallons per minute, and it'll be the maximum flow you can get through this. Having said that, talk about maximum flow rates, we're looking again at this bypass valve right here, and let's say for this particular unit you're using 10 gallons per minute of water in the field. Well, more than likely, depending on your hose size, for this you will be able to put 10 gallons a minute through this injector right here. We've talked a little bit about it before, but I'd like to go back and mention some things about this bypass valve in the fertigation loop on this irrigation manifold or apparatus. I get a lot of questions concerning the fertigation loop and why this valve, why isn't this plumbed in directly to the system. It really becomes important, especially for small farmers and people that are using a drip system that has variable plot sizes, which equates to variable flow rates. And especially if you are fertigating a plot that needs more water delivery or water volume to that plot than which your injector can supply, which what I'm saying is that you may be needing more water to the field which can flow through your injector. And this valve right here comes into play when you're in those situations. Also, you can use that valve to slow down or increase the speed of the injector. And how this particular unit works is that it has to have flow going through the injector to make the pump cycle. If it doesn't have flow going through the injector, it won't work. Everything in this loop, if everything's open, is in equilibrium. The water will take the path of least resistance, and it'll go through this line here. Because for this injector to work, it takes about 5 pounds of pressure for the machine to operate. Say if you're this unit is a 20 gallon per minute unit. Say you need 25 or 30 gallons of irrigation water to the field to water a certain plot, to drip irrigate a certain plot. Well, the maximum amount of water you're going to get through this is 20 gallons. This is where this valve comes into play right here. You want to fertilize and deliver 30 gallons of water to your field. Say that you can get a maximum of 40 gallons per minute through this main line. So you know you're good there on your water flow. What you can do, again, for this machine to operate, it has to have 5 pounds pressure differential. What you're going to do when your water is flowing and your system is pressured up, you can start backing off on this valve. And what you're doing is you're putting some restriction on the water flow and creating back pressure right here on this side of the injector. When the back pressure reaches, say, 5 psi on this side more than on this side, it's going to force water through the injector, which causes it to cycle. But at the same time, you still have water flow going through this main line unless you have this valve shut off all the way. It's going to be fairly how much you constrict the valve is going to be relative to the amount of water flow that you need in the field. So basically, once you're pressured up, you just bring the valve back until it starts to cycle the machine. And sometimes I can also give you some pointers later on about some things to watch for when using these particular units. And again, keep in mind that this is not the only type of injector or means of putting fertilizer in a drip irrigation system, but I particularly like these because they do have a lot of versatility on your ratios. This one has a wide ratio range, and it just gives you a lot more options than some of the simpler, cheaper ones. You have your system pressured up. You want to go ahead and start running the fertilizer. I would like to point out that my hoses here, the valves on each side of this main valve, are open. The system is equalized in pressure. To get the machine to pump, what we need to do is create a pressure differential between this side, the input side for the water, and the output side going to the field. Let's just assume that we're operating on a constant 50 psi. So basically what we're saying is coming to here, what we want to do is be able to raise the water pressure above this side by roughly 5 psi. If we've got 50 on this side, we'll probably end up having 45 on this side. And what we'll do to do that is just bring the lever back until we create the pressure differential and we actually get flow now going through. We've broke equilibrium and we've got flow going through the injector, and it starts to cycle. And at the same time, we still have the remaining, hopefully the water volume above 20 gallons per minute. We have our other 10 gallons a minute going through this here, because water is still going through this valve. It's not closed off all the way. We'll come back and maybe talk a little bit about header lines and field, what's actually in the field, including the drip tape. Before we say much about drip irrigation tape, I would like to say, in reference to the irrigation loop and fertigator loop that we talked about earlier, that this particular unit or this particular loop is missing a pressure regulator. And at some point in the irrigation line, whether you're using drip tape or orchard line or something else that's considered trickle irrigation, you're probably going to have a pressure regulator. In the case of the farm in which this unit is used at, the pressure regulators are located at each of the irrigation zones. At that zone, there's not only the pressure regulator, but each zone has its own main shutoff valve. On the pressure regulator, the next thing that you'll have, however, is you'll end up with a header line. And the header line is a larger line in which your actual irrigation tape or orchard lines will plug into or be fastened to actually deliver the water to your plants. Most commercial strawberry operations, or even smaller home gardener operations, may utilize drip tape as their water source. In most instances, the drip tape is incorporated into the bed laying and the mulch laying process by machinery and larger operations. The drip tape is probably one of the most important things that you can have, and you need to pay attention to if you're using, especially if you're using plastic mulch, because you've got to have a water source under that mulch to water your plants with. Generally, the drip tape, when it's laid in the bed, is about 2 inches below the surface of the bed. So it's actually laying buried, and this has several advantages to it other than laying it just under the plastic on the surface of the bed. You get water that is going to be closer to the roots because the source is already inside the soil, down in the root zone of the plant. And also, the drip irrigation line, this drip tape, has a tendency to expand and contract with heat, or potentially something could move it, slide it along the inside of the bed. So it being buried in the center between your 2 rows of strawberries helps keep it in place. I'd kind of like to explain a little bit about the structure and the capabilities of the drip tape. Generally, it is very thin. The thickness is measured in mils. This particular one right here is kind of standard. We use it in our plantings here at the university. It's called a 10 mil. It's 10 mils in thickness. The other part of the drip tape is the emitters. Now, what a lot of people don't understand is that the drip tape is not a soaker hose, in the sense that it is a soaker hose, but it put the emitters that are in the drip tape will put out the same amount of water no matter where you're at on the tape, out to a certain distance. Where say a drip hose or a soaker hose is more than likely going to put out more water closer to the source than it is the end. With the drip tape, within a certain number of feet, you're going to be getting even water through the whole length of the drip tape, which is very important, especially when you're fertigating, because you want to ensure that you have equal distribution of fertilizer to all your plants throughout a row. And this particular drip tape right here you won't be able to see them from this direction, but I'm putting my fingers, it has emitters every foot, and I've got my tips of my fingers right on where each emitter is. The flow rate on this particular drip tube is 0.45 gallons per minute per 100 feet. And that's an important number to know, is what your flow rate is per 100 feet, because that allows you to calculate the amount of water usage that you are using or you're going to use based on the length of the drip tape in the field. A couple of pointers. One pointer that I would like to mention about the drip tape is, in most cases, the emitter side of the drip tape needs to be up. Most of them will have some kind of blue stripe or a white stripe on the tape, so you can visually see which side needs to go up. The black side, the down side, won't have any, generally won't have any coloration, and it won't have any emitters on it. And the reason that is because even though your water is filtered, you're still going to have some particulates coming through the water. You want them to settle in the bottom of the hose and not settle in the emitters, in this case, which if the emitters are on the bottom, the tiny particles can eventually stop those emitters up if they're settling on them in the bottom of the hose. We spoke earlier about one of the most important things with setting up a drip irrigation system or any irrigation system is to know how much water you're going to use in your field or fields, and to know how much water your source can provide. We've drawn up a little schematic and done some calculations here to help show you how to calculate the amount of water utilization per minute that a given field might use with drip irrigation. First off, I'd like to show you that this is our field and our rows, and this represents drip lines. We've got 14 drip lines. This line here, however, is our header line that we talked about that our dripper lines are connected to. This is our water source, our fertigation loop, and I know you can't see it very well, but we've got a little valve and a pressure regulator right here. Okay, we're going to make some assumptions about this small field. We're going to assume that we're growing strawberries and that they're double rowed, and that we're using one drip line, a single drip line between each row. As mentioned, we have 14 rows, and our row length is 150 feet. The specifications on the drip irrigation line that we bought and installed says that for every 100 feet of this line, it will put out 0.45 gallons per minute. Now that's important. These are numbers we're going to use to figure out the water utilization of this field right here. The first thing we're going to do is, we know we got 14 rows that are 150 feet long. We've got to calculate the total amount of drip line in the field. And once we do the math, it comes out to 2,100 feet. Now what we want to do is convert that 2,100 feet into we want to know how many 100-foot lengths or segments is in that field. And we just simply divide 100 into 2,100, and we come up with 21 100-foot segments. Now, to figure out the total volume of utilization per minute of the drip line, we simply multiply 0.45 gallons per minute times 21, and the number we come up with is 9.45 gallons per minute water utilization by the field. And that's a theoretical number. There's a few things that might influence that. You know, we may talk about later on leaks. You know, there's some water efficiency factors that can be figured in, but theoretically that's what the drip lines in this particular field will put out, right at about 10 gallons per minute.